Hello, I'm Jason Ratcliffe, the home health expert, and welcome to this week's episode of Heal Your Home. This week's episode is slightly different as it is in a shorter format, and we delve in to go and see Adam Brown for Cornish Lime to see things all lime and how it can be applied to new and old properties. Hope you enjoy.
Heal Your Home with Jason Ratcliffe, the home health expert.
Yes, so thank you so much for taking the time out to come onto the podcast. And welcome everyone to the latest episode of Heal Your Home. I'm Jason Ratcliffe, the home health expert, and I am here with
Adam Brown
from
Cornish Lime.
Excellent. So if you could just tell us and the listeners kind of a little bit more about what you do.
Yeah, so Cornish Lime, family founded business, been operating for 30 years now, out of Bodmin. Our main area of business is producing lime-based mortars, renders and plasters. My background, I studied sustainable construction and surveying at Plymouth Uni. Worked there for about 12 years.
Yeah.
I'm now director and commercial manager, so in charge of hopefully day-to-day operations.
And in your time, it's I mean, obviously I've had a great privilege of having a look around, and it's amazing, and it looks like you've been developing huge, vast expansion stuff, so clearly you're doing something right.
Yeah, I think from a business perspective, we started out small-scale production. That gradually grew. More and more people started to understand the benefits of using lime. You could then pick lime up from virtually anywhere. So we sort of shifted our approach to, pre-made materials, custom-made materials, things that you can't get off the shelf.
Yeah.
Mainly sort of supply side of things, really.
And what type of buildings and clients are you kind of seeing utilise this now?
Anyone from homeowners that just want to patch up their wall, right through to, large development, multi-million pound renovations, do a little bit of new build as well. People want sort of the aesthetic look.
Yeah.
And again, churches, historical buildings, renovation, preservation type work.
It's really interesting because a lot of people may just assume lime is good for older buildings only. So you mentioned modern build, and what kind of modern builds would be useful for this?
So we do, within our range, we have a range called new build. So it is lime-based mortars and renders. Okay. So they give you the aesthetics of lime because people like that natural sort of colour. Yeah. They give you vapor permeability, so they'll deal with humidity better. They'll absorb moisture, release moisture, allow the walls to breathe. Also, it's quite good for building works. A lot of people will face their buildings and use lime-based materials because you can take the stone back out. So reuse and recycle becomes much easier. Again, it's a healthier option, sort of lower embodied carbon. Yes. Longer lifespan of materials, really.
Awesome. And that's, when you say longer lifespan as well, I think that's really important because so many people will look at the initial outlay or the cost and kind of, when looking at ordinary Portland cement, it might be a little bit more expensive. But actually, when you look at the longevity and what it can do for a building, it's like, well, actually, levels are better.
You're potentially getting twice the longevity out of using a lime-based material because it can flex and move with the building. Yeah. It manages moisture naturally. You're not getting degradation of your brick or your stone long term. Yeah. Softer. Long term it generally does pay for itself, hopefully.
And obviously with that flexibility as well, I suppose it would be quite good on timber frame buildings.
With rendering over panels, that's one area we do quite a lot of. Yeah. So we use a natural sort of carrier board. Okay. It is embedded with cement, unfortunately, but it's much more sustainable than, say, a cement board. Yeah. Then you use a flexible lime material over the top so it can accommodate sort of thermal changes, movement in the background, just tends to work much better.
Yeah. And from I suppose a new build perspective, it's how much are you seeing kind of uptake on this type of stuff?
A lot more people are definitely specifying the material. There are some pitfalls. I'll be perfectly honest, it's understanding the material initially, so it's not like working with sand and cement. There is a bit of aftercare that's needed, but a lot, I suppose from a development point of view, we're seeing right through from one-off sort of custom buildings where they want a specific colour or look, but we're also seeing sort of medium-scale developers, 50 to 100 houses. They are considering the use of lime as a mortar when they're facing stone or brick, because again, it's just slightly easier to work with, a bit more forgiving. Yeah. and if they do have issues, they can take it down and reuse the stone.
Cool. And am I right in thinking you guys not just you don't just manufacture these, you actually kind of give support and workshops for people?
Yeah, so as part of it, as the manufacturer, we have to give technical advice, but I'd like to think we've got quite a good technical team. So my background, obviously studying surveying, the two of the other directors were contractors for a number of years, so they've got sort of the on-site experience. And then our technical sort of R&D team, we've got a chemist, also a PhD in chemistry, and then two new hires actually that started last week. Wow. Both from uni off the back of chemistry. So I'd like to think we can try and cover all avenues if we can.
And what really kind of stood out as well is the attention to detail and the care that kind of going through every part of the process. It was attention to detail, and I think kind of the quality of each. I suppose the quality checks have to be there anyway, but obviously the level of care that's gone into the products. I think that really makes you, to me, stand out when I'm kind of looking at other manufacturing and products out there.
I hope so. I mean, everything that we manufacture is CE marked, so it has to go through specific tests and checks. It's not just sort of something we're making in the backyard like we used to. Yeah. Many years ago we were, but with I suppose the lab team that we've brought on board, they're able to undertake all the testing. We also are ISO 9001 accredited.
Cool. So and for those that don't know that,
I'm not the best one to ask, but it's basically we use it as a manufacturing system. So there's there's a framework that we follow for all of our production, so we can basically trace back and check every single material. Certain paperwork that we have to do, so that puts a lot of those checks in place. We basically follow that system to manufacture too.
Because ISO can be quite stringent, so you have to be really on it.
There's sort of yearly audits, so we have to prove that we're actually doing the paperwork and doing those checks. As part of that, the research team, they'll have to take X number of products every month, put them through testing, sort of pick them randomly from the pallet, just to ensure we can prove that the materials actually are designed for purpose and doing what they say.
And so if somebody was coming to you or wanted to use your products, if they were a homeowner, for example, can they go directly to you?
So we supply direct to trade and homeowners. We also supply through a number of merchants and other lime companies. But people can come direct to us. We've got hopefully a lot of guidance on the website. There's lots of articles. More than happy to speak to people, guide them through each stage of the process. Hopefully within the team there's someone that can answer right from application right through to aftercare. I think we can cover that.
Amazing. And everyone I met as well seems super engaged in what they're doing in their individual stuff, which is nice. No one ever looks like, I've got to go to work today. I mean, we all have those days, but I think, they truly care, obviously, about their role within the company, and I like that. That's cool. So going on obviously to more kind of technical stuff or the usability of this in older buildings, we've covered previously in this show why ordinary Portland cement may be a detriment to older buildings, if it's stone, cob, etc. But what's the bigger advantages of using Cornish lime or general lime plasters and renders, that kind of thing?
So with a solid wall, obviously no cavity is present, so you're dealing with a structure that will have moisture in it. It's inevitable. Historically, the walls were designed basically to a thickness that would keep the internal occupant dry, because they knew water would get in, and the lime mortar or the earth mortar they used historically would manage that process. So it allows it to come in, allows it to go back out again. Older buildings, again, because there's no cavity, as they get wet and dry out, they heat and they cool, they will expand and contract. So the mortar, it's a moving structure, all very minor, but using softer, sort of more vapor open materials, you allow for that movement. You don't get cracking, because when cracking forms, water can get in. So it's just trying to manage the moisture that will be present in the construction, really. Sand and cement, because it's much stronger, much denser, doesn't allow for that movement to occur. And then it occurs through the stone or the brick. Then you get issues with sort of erosion or material failure.
And accelerated water ingress. And I think a lot of people as well, I've seen it, and it's almost heartbreaking, where they know that bit, but then they'll go and get a normal painter and decorator to put some kind of weather shield on the outside, and it's kind of goes, oh.
Yeah.
I mean, from that kind of perspective, you know, what kind of paints or finishes do you think would be appropriate for lime renders?
So the first thing we always tell people is if it says breathable, don't trust it.
Okay, interesting.
So the term breathable doesn't actually mean anything. There's 2 dictionary definitions for it. It means that it's suitable or pleasant for breathing, so it's not going to kill you, or it's something that allows air to pass through it.
Right.
So there's a massive issue within construction because the term breathable is just a really great marketing term.
Yeah, absolutely.
In terms of paint, it's generally believed that the term breathable paint was coined from the fact that they were using less VOCs.
Okay.
So it was safe to be in the room when you painted.
Okay.
It doesn't have any relation to moisture. So
Wow, okay.
there are some specific tests or data that you can use. The first one's called an SD value.
Okay.
It stands for steam diffusion. It's basically a measure of resistance.
Okay.
So the lower the value, the more moisture can pass through that paint coating.
Right, okay.
And the figure that you want to aim for is between 0.01 and 0.05.
Right.
There are, a huge number of paints on the market that achieve that.
Yeah.
So you've got traditional paints like lime wash, mineral paints, there's clay paints, emulsions. They can all do that, but just you need to look out for that SD value figure.
Right. Is there any other tests that we could do?
The other one that you can look for, so in terms of moisture, SD is like the leading one.
Sure.
It's a German measure, but all companies that are selling truly sort of breathable paints will have that.
Yep.
The other one is more for external applications. You want to look at how much water is being pulled in by the paint.
Okay.
Because one thing you can have a truly vapor open paint that's allowing moisture to pass, but that might allow too much water in.
Sure.
If you imagine you're on the edge of a cliff somewhere in Cornwall,
Yeah.
sideways rain, you could have an issue with that paint soaking up too much. So the figure there is a W24 value.
Right.
That's a measure of absorbency.
Okay.
So again, the lower the figure, I think generally people accept 0.06 to 0.12.
Yeah.
Again, I can't remember the exact, so it depends on where you are.
Yeah.
But that will tell you how much water is going to be soaked up by the paint as well, so it's something to look out for.
So it's kind of like a fine balance then between breathability and obviously making sure that it's not going to be too breathable.
Yeah.
Yeah.
It's moisture in gas form and then liquid.
Yeah.
In, sort of physical water. You've got to allow for both. If you're internally, not so much of an issue. You don't need to worry about it being water repellent. Externally, it's something that I would focus on, especially if you're in sort of a really exposed environment.
Yeah, so it's almost kind of, if you've got, say, one side cliff face, another side maybe sheltered, then maybe looking at an alternative for orientations, or would it be cheaper just to do the whole thing?
Probably cheaper to do the whole thing. So traditionally, lime wash was the only paint you could really find. There was a couple of variations of that, but the way lime wash works is you basically just slap it on and keep building it up.
Right.
So we know historically in Cornwall, people were redecorating every 6 to 18 months, and you basically just keep building the paint up.
Yeah.
The more layers you put on, the better it is at sort of performing.
Yeah.
People also added additions like linseed. That makes it slightly more water repellent.
Okay.
But thankfully now, with sort of advances in technology, we've got paints that can allow for moisture to move through them freely, and they will repel liquid.
Right, okay.
They're not waterproof because that will seal it,
Yeah.
but they can stop a lot of water entering. So
Yeah.
long term, you get that sort of moisture is able to move,
Yeah.
but you're not pulling in huge volumes of liquid water.
Right, and I suppose inside as well. So if you've got plasters or anything or normal paints inside of a wall, quite often you can then see that blistering or blooming and damp staining, cracking, because obviously water's trying to get in. So what would you kind of suggest there?
So that sort of lifting or peeling that you see is generally hydraulic pressure. So you've got a build-up of moisture or water behind the paint layer. That paint layer doesn't allow for sufficient movement, so eventually water will always win, and it just blows it off. So it depends on the plaster you've got, obviously, because how that manages moisture is going to be the main driver.
Yeah.
But really, what a lot of people would do is try and scrape that paint layer off. The first step you could try is just try a better suited paint.
Yeah.
So again, a vapor permeable paint with that SD value range. Try that. You might have the wrong plaster, but that might buy you another 5 or 10 years.
Wow, okay.
I wouldn't ever recommend anyone goes in and rips off plaster unless they have to, because you're possibly opening yourself up for a lot of work.
Yeah.
Your budget's going to need to be stretched quite a lot more. So if a fresh, remove that paint, put a new layer of paint on. If that works for a number of years, great.
Yeah.
If not, then you possibly need to consider, the plaster that you've got behind, the mortar that's in the wall, using something that's better suited, like a lime-based plaster, that can manage that moisture long term.
Interesting, yeah. So I suppose you could then just, after hypothetically, if that worked for say 5 years, then you could then strip that down, do the repairs necessary, reapply, and then just, as long as you're happy to have that level of maintenance.
I mean, from our perspective, whilst the best thing I can do for a business would be to rip it all off. It's managing it as the as the homeowner or the tenant. You've got to do what works for you.
Yeah.
So it's almost a step-by-step process.
Yeah.
Whenever we tell people we're doing renovations, work out what the issue is.
Yes.
And then try and take the easiest steps.
Yeah.
To prevent those.
Yeah.
And then it's a process of elimination.
Yeah.
If that doesn't work, you know what the next step's going to be.
Yeah.
Okay, it might be more money, but you can try and move around that path.
And you can plan it. Yeah. So I know you guys are coming up with some really interesting new products and insulating performance kind of lime-based plasters, stuff like that. What would you recommend, or kind of from that basis, if someone said, look, it's a full renovation project, we're going to strip the walls down and put, say, a lime-based plaster on, from your kind of the options you have available, what would you suggest?
So the first thing we would always do is ask, is there a specific U value you're looking to try and achieve based on, U value software? That's going to point us into the direction of what's going to be the most appropriate. As it stands, we've got a current insulating plaster that we would generally recommend for everyone. A few reasons around that are it insulates much better than a standard lime. It's also much quicker to apply. Okay. So if you're doing it yourself or you've got a contractor in, there's a massive time saving there. We are just about to release a new one, which is much better in terms of insulation performance. So that would likely be the option, because you can use it at a much sort of thinner application, or build it out if you want to get a much better U value. A lot of people will just go with standard plasters as well. I suppose it depends on the budget. I mean, realistically, the insulating options in terms of their payback are always going to be much greater. Yeah. It's a bigger initial outlay, but with the thermal performance sort of benefits you get from it. Yeah. A standard lime plaster is relatively poor in terms of its insulation properties. Okay. So using an insulated plaster, there's boarded systems on the market. There's many options. We do a couple. They are very good in terms of insulation. A couple of things you need to consider with a board though, you have to have a flat wall. So a lot of people
that's out for most.
Yeah, that's where a lot of it falls down. A lot of people will then have to put maybe a 50 or 60 mil layer of plaster on the walls. Yeah. Then you fix your board. You've got to allow for that internal floor space. Yeah. If you're trying to achieve, let's say, a U value of 0.3, for example, a board may be the only way you can do it, because it's going to be easier to fix that. Yeah. If you're looking to go with maybe 0.7 or 0.5, a plaster can likely achieve that at a much sort of easier application.
Interesting. Okay. So I mean, 0.5 seems a lot more enticing, because a lot of these older properties don't have the privilege of massive internal space, so dry lining systems, that kind of insulation is really pointless in those situations. So those are where I think that would really kind of come to its own, because if you can then reduce that down, which that's massive, that's a huge saving.
Yeah, hopefully. Yeah.
I mean, that is. It's, because walls typically are huge, if you've got a big, say, 500-600 mil stone wall, that can be anywhere up to, 3 watts per metre squared Kelvin, which is huge. And then if you've got your insulation on that, which can be, 20-30 mil, in theory that could go down to 0.5.
I mean, with the new plaster that we're about to release, so its K value is 0.043, which is better than, it's on a par or better, slightly better than most of the boarded systems. Yeah. So a 50 mil layer, we know will take that U value from, we've tested it on, within our software that we use, we've got granite, basalt, brick, limestone, sandstone. We know for all those substrates, a 50 mil layer will bring you below 0.7. Right. Sort of 60, 65 is going to get you down to those 0.4, 0.5 values, which A board will do the same, but then you've got to consider you need your render or plaster on first,
Yeah.
then you need to fix your board and then plaster your board. So in terms of ease of use and cost, the plaster should be hopefully a better option.
And I could also see the board in time, if obviously it's not going to always be completely waterproof.
Yeah.
You know, it's going to start swelling, warping, deteriorating. So that's going to be more intrusive to repair than if you've got an insulated plaster, which you could then potentially just hack bits off and redo.
Single layer, one application, you can in theory patch that much easier.
Yeah.
I suppose it really comes down to what specifics do you need to hit.
Yeah.
There are times where a board is always going to be more economical. Let's say
Of course, yeah.
you're looking at achieving 0.2 or 0.3.
Yeah.
Depending on your background, maybe a board is going to be more cost effective.
Yeah.
It's horses for courses, really, I suppose.
Yeah, and you could potentially use both,
A combination of the two works.
Because if you've got big window reveals, which they often are in big stone buildings, you could then, obviously fitting board around that could be a bit cumbersome, whereas, having that insulated plaster could work quite nicely.
Yeah, also a lot of people will use them in conjunction, so say you've got to level off the wall first, because insulating plasters, again, most on the market are going to be relatively lightweight.
Yep.
You can put them on very thick very quickly, so you could use a combination of that to level the wall out.
Okay.
And then maybe a board on top just to further upgrade the insulation values.
So are they lighter weight than ordinary Portland cement?
Yeah, considerably. So again, I don't have the figures off the top of my head, but I think our new plaster has a density of around about 260 kilos per metre cubed.
Yeah.
A standard lime plaster, for example, is going to be, closer to 1,000. So it's going to be anywhere from 5 to 10 times lighter than a standard sort of cement or lime based plaster.
And I suppose when you're looking at something like cob, that's a massive deal, because a huge thing is obviously adhesion failure, drying out, things like that, and then it in theory can be a life-threatening risk if that falls off onto somebody. So if you've then got something that's permeable, that's going to be kind of keeping that wall as kind of moisture levels, hit that equilibrium as it should, but also is lighter, so it's not going to be affecting that structure. That's going to work a lot better than just insulating, right? Yeah,
it's a considerable difference. I mean, especially on historic backgrounds where you're potentially dealing with, like you said, much softer materials. Putting that additional weight onto them becomes a major issue.
Yeah.
So one area that we have looked at and need to do a bit further work is traditional sort of lath and plaster ceilings and walls. So if the customer wants to retain the lath, we don't always know the quality of the material. If you're putting on a very dense and heavy material onto a ceiling, the risk of that failure becomes quite high. The ceiling falling down is not great for anybody. No. So if we can create lightweight materials that don't stress the timbers, that will adhere and still perform as they should, it becomes a much greater long-term saving.
Absolutely, and I suppose restoration, keeping as much of the original character is obviously the end goal. But kind of moving on to the one of the big things which people worry about in these kind of restorations is damp, rising damp, that sort of stuff. Now you can't go in with your chemical injections and all this stuff in older buildings, but how would you kind of go about that?
Without being too controversial, I don't actually believe in rising damp.
Okay.
Might be right, might be wrong, just from the way I see it. Normally with, let's say, an older building, what we tend to find is it's usually really, really simple fixes. So the first thing I would always do before you do any work to the walls, check your roof, check your gutters. Because very often you'll find that possibly a tile slip somewhere or the gutter ends become blocked.
Yep.
Second thing is look for any hard standing ground. So one thing people often don't allow for is maybe a concrete path or paving. If that's too close to the wall, that's going to bounce a lot of water back up into the wall. Check for flower beds, ground levels. You've normally got very shallow foundations with an older building, but very often you'll find the external ground is higher. Look at installing a French drain around the outside to take that water away. In most cases, that will deal with a lot of the issues. Yeah. You then want to consider the building materials, the plaster, the pointing. As long as that can function and manage moisture effectively, the building will function. Moisture will be able to move through freely.
Yeah, fantastic. And I suppose all of these things inevitably will also help with black spot mold issues and things like that as well. I mean, it's not going to prevent them, but it will help.
It will help manage moisture. I mean, the other thing where people very often go wrong is ventilation is absolutely critical.
Yeah.
So the first thing I'll always advise people before you put any lime on the building, look at your airflow. Are you having sufficient air changes per hour? Because even with the most breathable materials in the world, if your relative humidity is too high and you can't bring that down, that material is going to stay damp. If it stays wet, a lot of people think, oh, lime's alkaline, it's mold resistant. It's not. Once it converts and sets, it's not alkaline. It's no longer alkaline. Mold will grow virtually anywhere.
Yeah.
But yeah, it will certainly help manage that excess moisture, but you do need to allow for good airflow.
Yeah.
Historic buildings, you had they were designed to be drafty. You had lots of open fires, lots of leaky windows. I appreciate people don't like that anymore, but ventilation is absolutely key.
Yeah.
You need to change that air enough.
Absolutely. And I think that you just hit that nail on the head, where people, it's that famous saying, well, it's been here for 200 years, there's nothing wrong with it. Yeah. But it's like, yes, if the building was maintained the way it was supposed to be, but coming with these new air tightness and in my personal opinion, the wrong way of kind of seeing these older buildings and trying to put new tech that would work in a modern build in an older building doesn't always work.
Doesn't always work. I suppose that the key thing as well, where we see a lot of buildings go wrong, is, for example, you've got a cement render on the outside. Client maybe, they remove that, they reveal a lovely looking brick or stone. They want to retain that. The first thing I would always say to them is, okay, the render was the wrong material, but it was probably put on with the best intention.
Yeah.
And what the issue is rainfall has increased exponentially over the years.
Yeah.
We are much wetter than we were. I mean, here in Cornwall, it literally rains for 40% of the year.
40?
Yeah.
Like
it might be higher, but on average it's about 40% of the year. But that rain comes sideways.
Yeah.
And we find a lot of these buildings, at the time, they were thick enough to deal with that.
Yeah.
But right now, they actually can't accommodate the amount of water they're subject to.
Yeah.
So the render is there for the best intents and purposes. It was just the wrong material.
Yeah.
So, and I understand people want to, see that brick or stone. It looks lovely. But we've also got to be able to adapt the building to function to modern day living.
Yeah.
And
absolutely.
the environment we find it in as well.
Yeah. Well, that's amazing. Well, thank you so much for your time. It's been really interesting. Is there anything else you want to say around this topic while we're here?
No, put me on the spot. No, I mean, again, it's just, I suppose the client doing the research, understanding the materials. The one thing that we always try and get across is lime isn't a magic bullet. No. It's not going to fix your damp issues. It's just the most appropriate material that we have. But it's understanding, like you said, the building as a whole. You can't just put one thing on and hope it fixes everything. It's taking that overall sort of approach and trying to manage the building effectively. Where can people find your products? Our website, cornishlime.co.uk. We've got an office and a shop, so if anyone's local, so pop in or give us a call. For specifiers, so all of our premix products, they're now on the MBS platform, so they can be dropped in. And can just contact us. Anyone that's got any questions or wants any further information, telephone line is always open.
Heal your home with Jason Ratcliffe, the home health expert.
Check out the website at homehealthexpert.co.uk for more information, to check out the services that we can help with for you and your family and improve your home's health, and also for the top tip guides that we have available for you. You can submit listener questions through our website and also by emailing our team at info@homehealthexpert.co.uk or by searching for Home Health Expert on Instagram and Facebook. We will try our absolute best to get round to your questions and help your family out to improve your home's health. Don't forget to subscribe to Heal Your Home wherever you get your podcasts, or on YouTube if you're watching along. Thanks again for listening, it really does mean a lot. We could not do this without you, and in actual fact it would be completely pointless. So please send in your questions, and I look forward to you joining me in the next episode of Heal Your Home. Your health, your future, it all starts here.